Hey everyone! In this video, we will explore buildings. Specifically, I wanted to explore the 1,000 tallest buildings. We will use building data in this video. Let's look at the Hagia Sophia for example. Getting its properties once again shows a wide range of data that we have on it. We can retrieve its height, for example. We can also get its opening date, which looks like it was almost 1,500 years ago. And we can also get the building's picture, which shows the beautiful building. This building is in Istanbul. What are some notable buildings there? We can use the with function, which lets me set up local variables, to make a new variable buildings. In this variable, we will use the entity class function to get buildings whose location is in Istanbul. On that entity class, we will use the entity value function to get both the name and position of these buildings. Now, inside the geographics function, we will set up a tooltip such that we can hover over the buildings to get their name. The object we're hovering over is going to be the first element, which is the geomarker of #2 or the second element, and here that would be position. In the second argument of the tooltip, we want the name, which will be #1 or the first element of our building's variable. This gives us the following neat visualization. Now let's explore the data. How are these buildings geographically distributed? We can plot a geohistogram to find out. Let's look at this code from the inside out. We will set up a variable top1000 which takes the largest 1000 buildings in terms of height using entity class. Using entity value, I can take the countries of each of these buildings. After that, I will flatten the data and use the counts function to tally it. Finally, I will use geohistogram to plot this and indicate I want it by country. We see a large number in the US and China. To get a more accurate picture, we can use a geobubble chart. This will plot bubbles proportional to the size of the number of buildings we have. We see that the US has over 300 of these 1,000 tallest buildings and China 117. Now on to another question. Who are the most prolific architects of these tall buildings? First, I wanted to get a list of all architects for our top 1,000 buildings. We will apply entity value on our data and get the property architect, and we'll proceed to delete any missing values and flatten the data. This gives us a list of all the architects for these tall buildings. What we can do now is apply the counts function on this data and reverse sort to arrange it in descending order. Getting a short form of this shows that Cesar Pelli is the most prolific architect of these tall buildings, followed by Philip Johnson. We can visualize this data using a word cloud. What about which materials make up the tallest towers? We will apply similar code here and get the top 1,000 buildings and their corresponding materials using entity value. Of course, we'll apply delete missing to remove missing data. Flattening the data and applying the counts function and then sorting it using reverse sort shows us that concrete and steel are the top materials. We can visualize this data using a pie chart and indicating our chart labels to be the keys of our popular materials variable. We can also use word cloud to do the same. As expected, concrete and steel are the most common materials. What about the most common architectural styles? Again, we'll apply the same code with entity value, but now retrieve the architectural style property. We can see a wide variety of styles by applying the short function on our style variable. Tallying it using counts and sorting it shows us that modern and postmodern architecture is the most common. We can visualize this again using a word cloud. I was curious, does this change with all buildings? Let's get the architectural style of all buildings in our entity class using entity value and entity class. Getting a shortened version shows a similar style to last time, but let's see how the tally looks. Tallying the entire data using counts shows us that modern is still up there, but neoclassical, Baroque, and Gothic/Neo-Gothic architecture make a comeback. We can visualize the new list using a word cloud too, in which we see the same trend. I was curious about how height is distributed. I'll first get the data using entity value and will then plot it using a histogram. We can see the distribution is skewed to the left. Most of these tall buildings look like they're under 1,000 feet. Also, how new are these buildings? We can find the oldest buildings in the data by calling the completion date property and indicating we want an entity association and then taking the smallest 5. This shows a lot of buildings in Egypt and also some cathedrals in Europe. We can also find the newest buildings in the data by using take largest. This shows us some buildings that are projected to finish this year as well as next year. I was curious about the frequency of construction of these tallest buildings and when most of them were constructed. We can do that by first grouping clean completion data by year and then taking the length of that data since we only care about frequency. We'll then encode that data in a time series. From the preview of the time series, we see that it covers over 4,500 years, and it looks like a sharp increase happened very recently. To make sense of the data, we can use date list plot with a plot range from 1900 to 2020 to see when these buildings were built. We see a spike in the 1930s, followed by a steady increase from the 50s onwards. I encourage you to make use of all the building data we have in the Wolfram language and really get to know the 1,000 tallest buildings.